Hi, I'm Madeline Cahulogan. I'm a geologist, and I currently lead the Geomatics and Hazard Assessment Service of the DOST-PHIVOLCS, where the GeoRisk Philippines initiative is lodged. Today, I will be discussing on understanding hazards assessment and relating this to the formulation of plans. At the end of this presentation, I expect you to correctly use hazard assessment results through the different GeoRisk Philippines platforms, including the PlanSmart application to smartly formulate plans and activities. If there is something common among all the GeoRisk PH interfaces, it is their ability to generate hazard assessments reflected through maps, graphs, reports, and planning documents. Through GeoRisk PH, we have made hazard information and calculation tools readily available to as many people and sectors as possible. We have developed the GeoMapper PH, the Hazard Hunter PH, the GeoAnalytics PH, and recently, the PlanSmart application. The reason that we have consolidated information and have automated several processes in the generation of hazard assessment reports and planning documents is for you to focus on formulating mitigating measures, preparedness initiatives for disaster risk reduction and management, or development plans. Despite the automations, however, human intervention and critical thinking are still necessary. Kaya, una sa lahat, mahalaga na maintindihan natin ang mga hazard assessment results mula sa iba't ibang ahensya. Para ma-explain ko ang hazards assessment at kung paano gagamitin ang PlanSmart, gumamit ako ng mga lugar sa Cavite, Legazpi City, at Cebu City. Simulan natin sa active fault. Ang active fault ay isang geologic feature na maaaring pagmulan ng mga lindol. Ang mga active faults ay pinapakita bilang pula o itim na linya sa active fault maps ng PHIVOLCS. Ang distansya mula sa isang active fault ay mahalagang malaman. Una sa lahat, dahil ito ang nagdi-determine kung ang isang lugar ba ay makararanas ng ground rupture o hindi. Ang location din mula sa active fault ang madalas na contributing factor sa mararamdamang intensity or lakas ng isang lindol. So, dito sa example natin, ang lugar na napili natin sa Cavite ay 4.4 kilometers mula sa West Valley Fault. Ibig sabihin, ang lugar na ito ay safe sa ground rupture. Bakit? Ang recommended buffer zone mula sa ground rupture hazard ay at least 5 meters mula sa active fault o dulo ng deformation zones. Sa ngayon, wala pang engineering measures laban sa ground rupture, kaya't minumungkahi na iwasan ang pagpapatayo ng mga critical facilities sa ibabaw hanggang sa dulo ng buffer zones ng isang active fault. Ngunit, mahalagang maintindihan natin na maaari pa ring i-develop ang mga lugar na mayroong active fault bilang low-use facilities. Halimbawa, maaaring gawing playground, garden, orchard, or parking space ang mga lugar sa ibabaw ng active fault. Kaya, sa pag-develop nyo ng comprehensive land use plan at pagdisenyo ng inyong mga programa, mahalagang tandaan ito. Dumako naman tayo sa ground shaking. Ang ground shaking naman ay ang paggalaw ng kalupaan dahil sa fault or trench movement. Dito sa napili nating lugar sa Cavite, mapapansin na kahit safe ito sa ground rupture, ito ay makaka-experience pa rin ng ground shaking. Ang ground shaking na naitala sa lugar na ito ay intensity 8 o lubhang mapinsalang lindol kung sakaling gumalaw ang West Valley Fault o iba pang mga active fault sa paligid. Subalit, unlike ground rupture hazard, ground shaking can be mitigated by strictly following the provisions of the National Building Code and Structural Code of the Philippines. Sa makatuwid, mayroong engineering solutions for ground shaking. Ang kailangan lang ay sundin ang mga ito. Ang earthquake-induced landslide naman ay landslide na sanhi ng malakas na paglindol. Nangyayari ito sa mga kabundukan o mga kalapit na mga lugar sa mga bundok. Mapinsala ang hazard na ito na kayang tabunan ang buong komunidad, gaya na nangyari noong 2012 sa Negros Oriental. Isang buong komunidad po ang natabunan ng earthquake-induced landslide. Early warning against earthquake-induced landslide may be tricky or challenging because the warning of the impending landslide is the earthquake itself. Hence, if possible, avoidance is recommended for sites that are prone to earthquake-induced landslides unless appropriate engineering interventions are in place. Dumako naman tayo sa liquefaction hazard. Ang liquefaction ay nangyayari sa mga kalupaan na mabuhangin, maburak, at matatagpuan sa mga patag na lugar, sa mga floodplains, mga ilog at coastal areas. Ang liquefaction ay hindi nakamamatay, subalit lubhang magastos kung maaapektuhan ang mga gusali at iba pang man-made structures ng liquefaction. Gaya ng kalsadang ito na naapektuhan ng liquefaction noong February 6, 2012, dulot ng magnitude 6.9 Negros Oriental earthquake. Bago pa man mangyari ang earthquake events, mahalaga na isaalang-alang ang mga probisyon ng ating National Building and Structural Codes laban sa liquefaction. Ang huling hazard na kaakibat ng lindol o iba pang geologic events ay tsunami. Ang tsunami ay nagaganap dahil sa paggalaw ng trenches or active faults na nasa karagatan, pagkakaroon ng landslide sa dagat, at sa bihirang pagkakataon, pagbagsak ng mga bulalakaw or meteorites. Ang isang volcanic eruption din ay maaaring maging sanhi ng tsunami. Ang mga warning signs ng tsunami ay ang malakas na pagyanig, malakas na dagundong sa dagat at hindi normal na pagtaas at pagbaba ng dagat. Dito sa Pilipinas, marami tayong coastal areas. At ang mga coastal areas na ito ay nahaharap sa panganib ng tsunami. Ang ibig sabihin ba nito ay hindi na natin i-develop ang mga coastal areas? Ito ay isang malaking kawalan para sa ating gobyerno at sa mga negosyante. Kaya, ano ang pwedeng gawin? Marapat na alam ng mga tao ang evacuation routes at evacuation sites kung magkakatsunami man. Ang komunidad ay maaari ring magtulong-tulong upang magtanim ng mga mangroves. Napatunayan na ang mga mangroves ay maaaring sumalo ng mga debris na nakamamatay na dala ng tsunami waves. Kaya, kung kayo ay nasa baybayin, ang tsunami hazard ba ay nakonsider nyo na sa inyong mga DRRM plans? Ladies and gentlemen, I hope that by now, you can integrate all concepts presented and strategically formulate your pre-disaster plans to mitigate and prepare for seismic hazards. Let's proceed to volcanic hazards. For volcanic hazard assessments, it is important to know what the permanent danger zone or PDZ and extended danger zone or EDZ, if any, and the hazards map for a particular volcano. In Mayon volcano, for example, the permanent danger zone is 6 kilometers around the volcano. A permanent danger zone is a zone that can always be affected by small-scale eruptions. Human settlement is not recommended within the PDZ. In this example, we see that the area being assessed is 6.4 kilometers southeast of Mayon volcano. Therefore, it is outside the permanent danger zone but is inside the extended danger zone. If you look at the map, the location is prone to pyroclastic density currents. Pyroclastic density currents are a mixture of fragmented volcanic particles, hot gases, and ash that rapidly move outward the source vent. PDCs, or pyroclastic density currents, are the most lethal of all volcanic hazards. Lava flows are molten rocks moving downslope or away from an eruption vent. Di gaya ng pyroclastic density currents, ang lava flow ay mabagal ang pagkilos. Kaya't walang sinuman ang mamamatay sa panganib ng lava flows. Ngunit sa agricultural lands, malaki ang epekto nito. Dahil ang mga madadaanan ng mga crops o ari-arian ay masusunog at ang lupa ay magiging di kapaki-pakinabang dahil mako-convert ito sa bato. Dapat itong isaalang-alang sa mga plano. Ang ashfall naman ay panganib na dulot ng mga abo or volcanic fragments na binubuga ng bulkan na bumababa sa kalupaan dulot ng gravitational force. Mapanganib ang ashfall dahil ito ay may kabigatan at mapaminsala sa mga ari-arian, kagaya ng mga agrikultura, mga bahay, at mga gusali. Higit sa lahat, lubhang mapanganib ito sa kalusugan, especially sa respiratory system ng katawan. Ang isang lugar ay maaaring maabutan ng ashfall, depende sa lakas ng pagsabog ng bulkan, volume ng volcanic materials na naibuga, at direksyon ng hangin sa oras ng pagsabog ng bulkan. Tingnan naman natin ang lahar. Lahars are a mixture of volcanic sediments, debris, and water that cascade down a volcano slopes through rivers or channels, kagaya ng example natin dito. Lubhang mapaminsala ang lahar na kayang matabunan ang buong river channels at mga nakapaligid dito. Kagaya na nangyari sa Sacobia, Bamban River sa Pampanga noon. Lahar threat to people's lives can be addressed by, number 1, observing or implementing legal easement adjacent to riverbanks as provided in existing laws, ordinances, and land use plans. And, number 2, community preparedness and evacuation plan. At-risk communities must learn to evacuate themselves when lahar threats are imminent. Other volcanic hazards include emission of hazardous gases that may contaminate groundwater or that may be odorless and may go undetected, poisoning communities. Ground fissure may also occur in volcanic areas. Damage to man-made structures may also be experienced due to ground shaking resulting from volcanic earthquakes due to magma ascent. So far, I've discussed earthquake and volcano-related hazards. Again, it is important to consider all concepts and assimilate these in pre-disaster planning. Now, let us have a quick look at hydromet hazard assessments provided by the Mines and Geosciences Bureau, or MGB, and the DOST-PHIVOLCS. Under hydromet hazards, there are 4 hazards: rain-induced landslides, floods, storm surges, and severe wind. Let me read the agency's recommendations as to the hazards mentioned. For areas prone to rain-induced landslides, there is a need to implement appropriate mitigating measures as deemed necessary by project engineers and local government unit building officials. Monitoring of signs of ground movement such as tension cracks, tilted trees and fences, and bulging road sections in areas that are moderately to critically susceptible to landslide should be done regularly and reported to local authorities and/or the Mines and Geosciences Bureau. For flood hazards, there are corresponding flood heights for each color represented on the map. The number of days are also determined. Let's proceed to DOST-PHIVOLCS data. Based on PAG-ASA assessment, coastal areas are prone to storm surges, like tsunami. Storm surge is a catastrophic and life-threatening hazard because it can cause massive inland flooding, sometimes in unimaginable heights. It is even more dangerous when the storm surge coincides with a high tide. Lastly, severe wind hazard. According to PAG-ASA, for those areas identified as high risk to wind damage, building codes and regulations must be strictly implemented. For already developed areas, retrofitting is encouraged. Now let's proceed to our second objective. How do we relate all these learnings in PlanSmart? There are two stages in using the tool. One is before a disaster, and another is after, which considers actual data on the ground. Let's start with pre-disaster rehab and recovery planning. We use worst-case scenario maps to conduct assessments. In this figure, we see a portion of the PlanSmart that displays a rain-induced landslide map on Cebu City. The graph indicates the percentage of the land area affected by rain-induced landslide. We also see charts and tables and lists. Based on the available data, we need to imagine possible scenarios in order to strategize. We need to formulate relevant questions. For example, given this information and barangay scale hazard assessments, how do we design our land use plans? Where will we put our commercial centers or our agricultural lands? Where will we construct government infrastructure? Or how do we design our PPAs? Another question would be, given the distribution of male, female, children, youth, and senior citizens, how do we design evacuation centers? And how much would those specialized facilities cost? Now I ask, do you have these considerations in your PPAs? Let's proceed. In the PlanSmart app, we could select a particular sector, for example, housing and settlement, and propose budgets, short-term or mid-term. LGUs or agencies may add as many PPAs as necessary. All this before a disaster. After an event, LGUs may identify exact locations of damages, as shown by the blue polygon in this figure. So we have the building footprints represented by red or pink polygons, and the blue polygon here would represent actual area of damage. Kung mapapansin ninyo, napakahalaga na kumpleto ang inyong exposure data bago pa man ang sakuna. Bawat building dito, kung kumpleto ang inyong data, ay maglalaman ng mga impormasyon kagaya halimbawa ng halaga ng building or structural integrity ng bawat building o ilan ang nakatira sa bawat bahay o building footprint na nakarepresent dito at iba pang mahahalagang detalye. Given this polygon, for example, PlanSmart can automatically calculate the needed assessment and summarize results for rehabilitation and recovery or for post-disaster assessments, which will be the basis for the next cycle of pre-disaster planning. Based on post-disaster information, PPAs may be revised as necessary and communication strategies may be developed as well. I hope that you've learned from this session. By now, you should be able to understand hazards assessment, and you should be able to relate hazard assessments in the formulation of your plans. The use of GeoMapper-PH and PlanSmart will help you and your LGU streamline several processes from collection of exposure data, mapping of land use, retrieving hazards information, developing programs, projects, and activities, and generating a planning document itself. Continue to use PlanSmart. Provide us your feedback. And together, let's improve the system and develop more science and evidence-based DRRM and development plans. Kaya natin to!